Hello everyone, this is me Arjit with a new video, and in this video we are going to talk about a very interesting project which is custom object detection. So in this video I am going to show you how you can use a custom dataset to train a custom model in YOLO version 8 so that you can actually detect custom objects. Now in this very particular video I am going to use the example of license plate detection. So I'm going to use a data set of license plates and I'm going to train the model so that using the model we can detect the number plates. But the similar code and the similar template, all the similar concept you can use to train any model, and I will actually show you how you can change the data set and some other parameters to train any other model you want to train. Now coming to custom object detection, the main problem people face is like that is the very first thing is where to get the data set. Now the next is like which model to which model or which architecture to use. The third is which libraries to use. Then there is which version of libraries to use, because then there is this version of library which doesn't work with that version of library. So which version of libraries to use, and finally where to train the model. Let's say I don't have a very powerful machine to where to train the model. And to solve all these problems in this video, we are going to use firstly Google Colab. So you don't need any powerful machine. You can train your model in the Google Colab. The second thing is I'm going to give you a template. You can use that template. So here all the libraries with their required version numbers are mentioned. So you can actually install all of them in a single line of code, and then using the same template you can actually train any model. Okay. So that's all the things we are going to cover in this video. So it's going to be a very interesting video. So without wasting any time, let's get started. Okay everyone, so in this video we are going to do all the things step by step. So when basically you have to train a custom model, the very first thing is obviously you have to find a data set, okay, or you have to make your own data set. Now making your own data set, that we are not going to cover in this video. For that we are going to create a very separate video, and maybe the next video we are going to make on that. So in this video I'm going to show you how to find a data set, because like for most of the normal objects you are going to most of the times you get a data set. So how to find a data set and how you can actually get the data set in Google Colab, and then how to train. So that is the main focus. So here for that purpose you can actually use RoboFlow. Now in RoboFlow you are going to if you go in RoboFlow you are going to get a lot of models. Okay, so let's say this is the RoboFlow site, and if you go to RoboFlow universe in this way, so this is the link universe.roboflow.com. Here you can search for different kind of data sets. So for example in our case is license plate. So if you just search for license plate, multiple data sets you will get. Like there is this one data set, you have 2500 images, then there is this one, okay, this one, and license. So if you give license plate like detection something, I think more data sets you will get even. So you see there is this data set which had 7.5 thousand k images. This one has 1.8k images, and a lot of data sets are there. Not only one, multiple data sets are actually there. Okay, so for let's say you want to go for bird, let's say, okay, so if you just search for bird, yeah, so there is a data set for bird. So like for most of the normal objects you will get you may get a data set here, and even if you don't get a data set here, in that case also you can actually upload your own data set here, and then basically if you can also level it. So how to level your own data and how to level your data set, that thing we'll cover in a separate video. Okay, but if you already, so maybe from somewhere else you get a labeled data set, okay, in that case also you can actually upload the data in RoboFlow, and from RoboFlow it's very easy to actually get the data in Google Colab. So for example in this video I'm going to use this data set, okay, and this data set actually we have uploaded. So one of my teammates has uploaded here. So we got the data set from GitHub, and from there we have actually uploaded it here, okay. And if you see there are total 395 images of vehicles, and if you see, if I just show you any of the image, you see all the images are already labeled, okay. As you can see the images are already labeled. So as you can see the classes are this, and you can see the license plate is the only class here, okay. So you can see all the different things, and like the raw data and everything from here, okay. So annotating the data, labeling the data, maybe we can discuss a separate video, but the point is that here the data set is labeled, and in RoboFlow if you go for any data set, most of the data sets here you are going to get labeled, okay. Now these are the raw images. Now if you go to dataset, you are going to get this, that as you can see the dataset has been the last time it was updated is August 31 2003. So just 3 days back we have just updated a dataset. Okay, now once you got a dataset from, let's say you got a dataset from RoboFlow, or you got it for somewhere else, a label dataset, and you can just upload it in RoboFlow. That also you can do. Once you do that, the next thing is you have to come to dataset, from the menu dataset here, and there you will see it is going to split your dataset into train set, valid set, and test set. So our dataset is very small. Now this is a demo video, like how, so the purpose of this video is to teach you how you can train a custom model. So that's why I have not taken a very big data set. So I just shown you like there are license plate big data set where you have like 8,000 9,000 images, but I'm not going to use that, because if you have a smaller data set, the time required will be also less. Okay, but even we did this data set also, we are going to get a good accuracy. I'll show you at the end. So this is the train set, this is the valid set, and this is the test set. So 70%, 21%, 9% is the split. So it will automatically going to split the data set, and also it's going to create the folders. So when you will download the data set, you will see there is a train folder, valid folder, and test folder. So everything it's going to do it for you. Okay, even it's already it's pre-processed, so all the images are already stretched to 640 by 640. Okay, and as you can see, no augmentation has been applied, but if you want augmentation you can also apply, so the number of images will get increased. Okay, now I will give you the link of this dataset, so you just go to this link. So if you want to just train the license plate detection, you can just go to this link. From there you have to just log in. It's free, you just have to log in, and from that what you have to do is you have to download the dataset in the specific format. So in this video we are going to use YOLO version 8. Okay, now if you don't know what is YOLO, YOLO is like you only look once. So basically it's a very good accurate object detection image segmentation model. Okay, and version 8 eventually is very accurate, I would say, and it is actually made by Ultralytics. So as we are going to use YOLO version 8, that's why we have to download our dataset in this YOLO version 8 format. So you just have to click on this, and once you click, you have to go to, you don't have to download a zip to your computer. So if you are going to train your model in your PC, if you have a powerful PC, you are going to train it in your computer, you can download a zip. Obviously I'm not going to do it. I'm going to train in the model in Google Colab. So I'm going to do show download code. So you just do continue, and it will just zip the file. It will get the file ready for you, and it is going to give you this link. So you just have to take the link from here and you have to paste it in your Google Colab, and you have to just run the code, and then you will have the dataset. So I'll show you. So this is the dataset part, that if you got your dataset from RoboFlow, that's best. It's very easy. Just search the dataset, come here in the dataset, select your model, YOLO version 8 in our case, and just come here and you just download this code. And so one thing is there, if you download a very big data set and then you try to upload the folders directly to Google Colab, it's not going to work. Google Colab will hang in most of the time. So this is a very good way of getting the data set in your Google Colab. Okay, and also it's very fast, so it takes a very less amount of time to download it in Google Colab. So this is the data set part. Okay, now the next thing is the code, and I already said we are going to code it in our Google Colab. So this is how Google Colab looks like. So if you're very first time if you don't know how Google Colab works, you can just go for Google Colab. You just have to have a Google account, nothing else. You can go to Google Colab, you can create a new notebook, and you will get something like this. Okay, now what is very important is, I'll just show you. So what is very important is, if I show you, this is the code you are going to use. So here, if you see, if you go to here, the drop down, and if you go to view resources, there, if you're doing it for the very first time, what you will see is you are not going to get the GPU RAM. So you have to go to change run time type, and there you have to select T4 GPU. Once you select that, then only you are going to get the GPU. Okay, so you have to select the GPU, and then only you will get it. And after that, once you select that, you just, here you will get a reconnect option. Just click on it and it will get reconnected, and you will get something like this, a RAM, DISC, and T4. So make sure T4 is written here. That means you are getting the T4 GPU. Without GPU also you can run it, but it will take a lot of time. So I don't recommend that one. Okay. So this is about the Google Colab setup. Very simple. Come here, go to view resources, change the runtime, select T4 GPU, click save. Here I can, because I'm already running GPU in my one Colab session. I cannot select here, but you have to just click here, save, and next you just have to click on connect. That's it. You are done. Okay. Then the thing is, you have to go to our GitHub repo. The link will be in the description as always, and there you are going to get the Colab file also. Okay, so from here, so what you have to do is, first you have to download this whole GitHub repo in your desktop, and from there, so let me just I'll not do it, but I'll just tell you that you just download this, because I already have opened this file in Colab. You download the whole folder, then you come to Google Colab, you click file, you click open notebook, from there you go to upload, you just choose a file, and you are going to choose this file, this license plate detection YOLO v8.pynb. This file you select, and once you open this file, this is how it will look like. You will have all these things there. Okay, now only one thing you have to do. What you have to come here, that thing you have to do, that you have to go to a drop down, and from there you have to go to manage this view resources, and you have to select the T4 GPU, so that you will get the GPU here. That's the only thing you have to do after you open the notebook. Now let's see what we are doing inside the notebook. Okay, now the very first thing we are doing here is, as you can see, we are cloning our GitHub repo. Why we are cloning our GitHub repo? Because inside that we have the Ultralytics files, and also we have the requirement txt and the demo files. Okay, now first you have to clone our repo. You can just clone our repo, and once you clone our repo, you are going to get that license plate detection using YOLO v8. You will get it here. Next you have to go to the folder, so you just do cd and the name of the folder in this way. So similar, nothing you have to change. You will get into this folder. Still now we haven't downloaded a dataset. It's very important. Next is, here we are going to download a dataset. This is the important part, and here you have to paste that link. If you remember, this whole code you have to paste here. Now this code will not run because I have removed my API key. You just take the code from here and you paste it here. If you're using some other data set, paste that code here and you just run it, and it's going to install RoboFlow for you, and as well as it is going to download the data set for you. Okay, within few minutes, so depending on the size of the data set, it's going to do that. So it will download the whole data set for you. So once you run this thing, so I'm not doing it because this all the process, it takes some time to download data set and all that. So I have already did it, but in your case you have to do it, all the things you have to do it. And then what will happen, you are going to get this license plate detector file. Okay, and inside that, if I just show you, you are going to get, like I said, test train valid. Okay, test train valid. So inside test you have the test images, inside train you have the train images, and also labels, not only images and labels. And inside valid you have the valid images and the labels. Okay, that's all you are going to have. And also there is a data.yaml file. This file is important. This is one file that you have to change, and I'll show you what things you have to change in the file. Okay, so once you download the dataset, you will have something like this. So let it be here. Next you have to install the libraries, required libraries. So here we have a requirement.txt file. So if I just show you, in the requirement.txt file, I'll just put it here, requirement.txt file, we have everything here and all the versions we have mentioned. So Ultralytics 8.0.3. Why I have mentioned the version is because in sometimes, like if you change the version a little bit, you will have a lot of issue. So all the versions are mentioned, and based on that, it is going to download the libraries. So you just have to run this code, that pip install requirement.txt, and it is going to download all the libraries for you. You don't need to do anything. Okay. So at this point, you have downloaded all the libraries, you have downloaded the data set, you have downloaded a data set, and Ultralytics file you already have. Okay, here we have the Ultralytics files. Okay, so now we are actually ready to train our model. Now before we train the model, so this is the command that is going to train our model. So let's look into it. What we are doing here, we are using Python to run the file. Next is, here we have to give the train.py file location. So where is the train.py? If I just show you where is the train.py is, just give me a moment, I'll just put this thing here. Train.py, if you see, here is the train. So you have to go to Ultralytics, and from Ultralytics you are going to have the YOLO From there you are going to have the version 8. Inside that you have detect. Inside that you have train.py, also predict.py. So here you have the files. So here we have just wrote the whole path, contain and that and train.py. So train.py is the file which is going to train your model. Next is, which is the base model we are using. We are using YOLO 8 and YOLO V version 8 n.pt. This is the base model we are using. Now there are separate model also, YOLO version 8x, YOLO version 8, different models are there. So if you want to use them, you can use. If you know YOLO, you should know there are several models there. I'm going to use 8n. 8n will be fine for me for in this case, but YOLO 8x also you can use, up to you obviously. Okay. Next is, we have to give the link of the data. Now how to give link of the data? We just have to give it the link of the data.yml file. Okay. Now here you may have to change the dataset path. So I'll show you what you have to do. Let me remove the whole path. Now the data equal to, there is no path given. What you have to do is, you have to go to your dataset, open it, find the data.yml file, copy the path, and here you just paste it in the data. Okay, you just paste it here and a space. Okay, so now you have the data.yml file. Let me data.yml file path, and finally you mention the number of epochs. Here for this demo I have put it 100. Based on your requirement you can just put it, and also you have to check the data and all the things. Based on that you can change the epoch. Okay, for now I have put it just 100 only. Now one thing you have to change, what is, so once you open your data.yml, your data.yml is going to look like this. So I'll just show you. I have modified it already, but I'll show you how it will look like in your case. So in your case it is going to look like this, your data.yml file. So here at the very end you have the train and validation folder path. And the path is based on that it's going to give you the name of the main folder, which is license plate detector 1. So the name of the folder of the dataset, and then train and images and valid and images. But in our Google Colab, we also have a path, like the whole dataset is inside this license plate detection, this folder. And this folder is also inside the contain folder. If you know Google Colab, all the things are inside the contain folder. So this, if you run this thing, it is going to give you an error that, hey, I cannot find these files, because it will try to search these files from the source. Okay, so that's why you have to change this paths. And how you can change? Very simple. You just have to copy your main this main folder path. You just have to copy that. Okay, and then you have to, or another thing you can do, instead of doing that, what it will be easier for you is, so there is train and validation. You come to your come inside this dataset folder. You copy the train path. You put it here. You are done. Oh no, not the train path. Sorry, not the train path. You have to give the image path inside train. You have to give the image path. So copy the image path inside train, and okay, this is a problem we get multiple times. Sometimes here it's hard to get it. Just give me a moment. So yeah, here in the train, what you have to do is, you have to copy the images folder, path of the image folder, and you have to put it here. Similarly for the validation, you have to copy the valid and images folder. You copy the path of the images folder and you put it here. That is the only change you have to do. Okay, this is the only change you have to do, and then you have to Control S. So you save it and you are done. Next, you can run this file. Okay, and once you run this file, it's going to take some time. So in my case it took 20 minutes, because my dataset is small. Based on your dataset and number of epochs, it will take some time. But as this Google Colab and the GPU is like very powerful, it will not take a lot of time. Okay, compared to your machine, I don't know if you have a powerful machine, different case, but in most of the times we don't have very powerful machines in our homes, not very powerful GPUs at least. So in that case, Google Colab will be faster. So, and after it will be done training, one thing is very important. At the very last line, it's going to say results saved to run/detect/train. This folder is very important. So basically it's saying that all the trained model has been saved in the runs folder, inside the detect folder, inside the train folder. Inside train folder you are going to get all the things. So you are going to get the result.png, which is so as you can see the graphs and all that things you will get. But the thing which you can check to make sure that yes, if it's working or not, so graphs also you can check, but if you don't have a lot of idea about graphs, you just check the prediction results. So val batch to pred. Okay, so as you can see here, so basically this is the val batch 2.pred, and as you can see all the numbers, so in the prediction it is actually detected all the number placed correctly. So that means your model is getting trained well. Okay, because as we know the validation images are completely different, but in validation images also it is doing the prediction quite well. So that means the training is going well and it has trained. And also if you check the val batch 1 pred, so that also you can check, just give it some time. So as you can see in batch 1 also the result is pretty good. So that means that model has been trained. So here now where you will get the model, so the model you will get in the inside the weights, you are going to have base.pt, last.pt. Now use the base.pt. So that is your final model. And also this base.pt I already uploaded in GitHub, so you can check it out. But it's not, I would not say it's the best model, because obviously the number of images we have used is very less and number of epochs is also not that high. And also the model is very small in size, so it's just 6 MBs I guess. So it's very small model, but still the model works, and I'll show you how good the model works actually. So from here you are going to get the model. So remember where your base.pt is getting saved, and you just copy the part of your model. You can also download it from here, just download. Okay, next, so our model has been trained. We have checked our prediction on the validation data, so you know like it's working. But next we have to check with a video or an image that how really good it is working. So for that I already have attached a demo.mp4 and demo2.jpg. So I'll show you how actually these two files actually look like. So I'll just show you from here. So if I just reveal them in Finder, so demo2.jpg, this is one demo image I'm using, randomly downloaded from Google. And this is also one
I want to show you first.
This is also one basically card video. I found some other video, so
yeah,
from other YouTube video. So also you can see this is basically the number plates here. Okay, so these are the raw files. Now we can actually run our model on those files. So what you can really do is here is the code. So this is the code to check with the video, that demo.mp4. so Python, the first thing is you have to give the predict.py path. Now predict.py path will be this same path, there will be no change. Okay, this predict.py you can find in the similar place where we found that train.py. Next thing is we have to give our model path, and model path, if you remember that base.pt we have just copied. So what you will do is you will come here and you are going to just paste the whatever the location is we have just copied. So let me just paste it. So here we are going to paste our path, which I have pasted the path, and finally you can paste the demo, you can paste the video file, video path or image path, whatever you have. So in my case is a video, and then so here I'm going to again run the same run the model actually on it, and I'll show you how the result actually look like. So here it is using the base.pt, and here it is going to check frame by frame the whole video and is going to save the video here, and from there we will download the video and I'll show you how the result actually looks like. Okay, so it's a very small video, so 631 frames there. So let's see, it will just take few seconds, and here we go, almost done, and here we are done. And if you see here where the result has been saved, to runs detect train 7, so you come to runs detect train 7. Okay, here you get the demo.mp4. let's just actually download the file. It's a very small file, will not take a lot of time. So it's downloading. So in the meantime it's download. I'll also show you for the image. So similar thing, everything's similar, just instead of the video, the image, and I'll run it. So here we are here we are done. Now video is also got downloaded, I'll show you, and image is also done. So and it's saving train 8. So let's just check train 8. So let's check the image first and then I'll show you the video. So train 8, we have the image. Let me open it for you, and as you can see, it has detected properly. Now come to the video. So as you can see in the video also, it is detecting the number plates quite well, as you can see. Okay. As you can see, it's detecting numbers quite well. Now also one thing we can do, we can actually check another random image from Google. So you can just go to Google, we can search for number plate car, something like this. We can search, we can go to image. I don't want to take this kind of images, a little bit bigger, where I have the whole car, maybe something like this not, yeah, maybe this is one. We have the car a little bit. So I'll just save the image, save image. I'll just give it a name, let's say number license plate LP, maybe a short name. Next, what I'll do is I'll just upload the image. So in my downloads I have the image LP, so I'll upload the image in this folder. Will take few seconds. LP has been uploaded. Now we will just say LP, just a minute, lp.jpg, and just run it and see if it's working on a random image from Google. And yeah, it's done. And if you're wondering why it's taking so much time for our image, remember that is actually loading the model. So it takes some time to load the model. Runs train 9, detect train 9, and we have the lp.jpg. And as you can see, it has detected the number plate properly. So this way it's working quite well. Okay, with a very small number of images, even I would say a very small number of images working quite well, and the number of epochs are also not that high, just 20 minutes of training, and it's working this good. So basically from here we can actually prove that with a very less number of image and less number of epochs also, you can actually make a good model. Okay, with YOLO version 8. Now let's say you have to train a different model. What things you have to change, you already know, but just a recap, you just have to change that RoboFlow code, so that instead of this dataset, you will download some other dataset based on that, and inside the dataset you have to change the data.yaml file. You have to give the parts of the test images and train images, and then what you have to change is you have to change, while training, you have to change the dataset path. Dataset part. Yes, dataset part. While you are going to train, you have to change the, what is the training code? You have to change the dataset path only, nothing else, just the dataset path. And when you are going to test your model, you have to change the your train model part. So if you see here, so that base.pt, so you have to know where the base.pt is, and you have to change this path, and also the source, based on what video or image you are using, you have to change the source path also. This is the only things you really need to change if you want to use the same model for if you have to use some other data set to train in YOLO version 8. These things you only have to change, nothing else. Okay, and coming to, if you have to make your own data set, maybe there is something you want to track and that's not the data set is not anywhere in the internet. In that case, you have to make your own data set. You have to bring the data, you have to label it, and you have to make a data set. That thing we are going to cover in a separate video. So very soon we are going to make this video, so stay tuned for that one. And I think that's it for this parts of the video. And I think if you have any questions, please let me know. You check this model, you check the whole code, and you can try different images and different stuff. You let me know how the results are, and if you have any queries, you please let me know. And all the materials I have used will be in the description, the GitHub repo, the link of the dataset, everything will be in the description. So that's it. So thank you everyone for watching this video, and I hope you have learned something from the video. So please hit the like button and also subscribe to the channel so that we can make more contents like this. And many more contents like this are actually coming very soon. So see you in the very next video.